we're going to look at how we can sort things in Java. So I've got here a list of names, and as you can see, they're not in alphabetical order. Obviously, names are a string, and with things like integers and strings, we kind of, if we're asked to put them in order, we understand what that means. So if we're asked to put a list of names in order, we'll put them in alphabetical order. Same would pretty much be the case for any strings. And if we had numbers, we'd put them in numeric order, starting with the lowest number, working our way up to the highest number. So in order to sort things in Java, if what we've got is a collection, so something like an array list or a linked list, then we can use collections.sort, and we can pass in our list. Okay, and now you'll notice as I'm typing that in, or actually when I type the brackets, you'll see that it says not null list question mark extends object nullable comparator question mark super object C. Okay, that's not terribly helpful, but that basically means we could pass in a list and something to compare the list. But when it has a natural order, like a string, we can just pass in the list itself. Okay, now to start typing list, you can see, in fact, actually, no, you don't need to worry about that. We can just pass in our list, which we've called names. Okay, and if we then were to, for example, print out the collection, it could be a reasonably well formatted collection. If I just print the entire collection, these should now be in alphabetical order, but we can run that and test it. Okay, and then we can go, we see C, E, J, A, N, J, A, S, M, I, C, M, I, N, and T. So all those names are in alphabetical order. So that's relatively straightforward. Okay. Unfortunately, not everything has a natural order. Sometimes we might decide that there is a natural order for something, but if we built our own class, unless we specify how it should do the sorting by default, you won't be able to sort it. So let's take another example. So I'm going to just comment out all of this for now. And you'll see we have a class called t-shirt. So let's just have a quick look at what t-shirt entails. So t-shirt has a color, a size, which is a size enum, and a price. Okay. When we create our t-shirt, we give it the color, which is a string, the size, and the price. We can get the color, size, and price, and we can change the price. We can't change the size or the color. Okay, now I think default ordering for a t-shirt would be to sort it by size. Okay, so if we were to sort t-shirt, we want it to be able to, I'll put it in a comment, want to be able to automatically sort by size. Okay, just to give an example of what size is, it's just an enum with small, medium, and large. We'll come back to this comment in a minute. Okay, so let's just go into my main class, and I'm just going to create a list of, or create an array list of t-shirt, t-shirts, I guess, t-shirts, and it's going to be a new array list. Okay, and then we'll add some t-shirts to that. So we can say t-shirt dot add. We can create a new t-shirt. We can pass in the color, brown. We can pass in the size, so size dot medium, and we can pass in the price. Now I've done the price as an integer because it's generally a good idea to work in the smallest unit of currency. So that would be pence. So if we had a 9.99 t-shirt, we'd pass in 999. Okay, let's just add a few more t-shirts of different sizes. Let's have a red one and a green one, and let's put the red one at $4.99 and the green one at $12.99. Okay, so, and let's change the size, so maybe make this one a large and this one a small. Okay, so we've decided, for whatever reason, and again, the reason will depend on what you're trying to do, but we've decided that the default ordering for t-shirts should be that of the size. Okay, so we could sort our collection of names by using collections.sort. So why don't we try and sort our collection of t-shirts with collections.sort, because after all it is still an array list. Okay, so we're getting an error before we even are able to do that. And if we hover over here, we'll look at, oh, there we go. It's saying no instance of type variables t exist so that t-shirt conforms to comparable super t. You might think that's not terribly helpful, but let's delve into a little bit more detail. So it says here required type list provided array list. Well, that bit's okay because it's not in red, and actually an array list is just a type of list. Okay, a little bit more on that later, so we're okay there. But t-shirt, it's saying t-shirt is not whatever t is, and t must conform to comparable super t, question mark super t. So something is, what it's essentially saying is that t-shirt doesn't implement or conform to something called comparable. Okay, well, let's have a quick look at string, because we know string does. Okay, so if we were to string x equals x, if we were to go to the declaration for that, you can see here it says public final class string implements comparable string. Okay, so that means that it implements an interface. The interface is called comparable. Okay, and an interface is essentially a description of how something should be, but without sort of defining how it works. So a bit like a blueprint, without the details of how you actually go about making something. So we need essentially our t-shirt to implement comparable. And in the case of string, comparable of string means it can be compared to another string. Well, we want to be able to compare our t-shirt to another t-shirt. So we need to implement comparable for a t-shirt. Now, if we were to look at comparable, comparable just allows us to compare something with another thing. Okay, and we don't really care what the thing is it compares with. So we've got this sort of thing here called we're using something called generics. Okay, so this is a type parameter, and basically says we can work with any kind of thing. Okay, now if we look at this interface, the only thing it actually has in it is a declaration of a method, but with no implementation, called compare to. Okay, and that basically means we need to implement a method that compares one object with another object. Okay, in this case string was comparing with another string, and it gives us a value to see whether one thing comes before or after the other. Okay, so if one object is less than the other object based on how we would order it, then we'd give a negative integer. If they're equal, we'd give 0, and if it come after it, we'd give a positive 1. Okay, so let's have a think about that for what we're doing with our project. So we need our t-shirt to be comparable. So we could say implement comparable. Now be careful here, because if you just hit comparable, okay, it will want us to be able to compare it to any object. Okay, so you could be asked to compare this t-shirt to a string, or compare this t-shirt to a car, or any other object you want to think of. That's not going to work. We really only need to be able to compare it to other t-shirts. So we want to say implements comparable for a t-shirt. Okay, it's still going to complain at us though. Okay, and it's going to say, well, you haven't implemented the methods. So the comparable interface declares that compare to method. So if we click on implement methods, it will add a method called compare to. Okay, and if we click it, it will say compare to t-shirt O. Okay, now that represents another t-shirt, so I'm going to call it other to make it a little bit easier to understand. Okay, so here is where we did do, if it comes before should be negative, negative, equal 0, sorry, negative, equal 0, and if it comes after, we want a positive number. Okay, so we could say, well, okay, we could manually say something like if size is equal to size dot small, okay, and then we can ask the other t-shirt for its size, and we can, even if we didn't have a get size method, it will actually let us access the instance variable, so we can actually do other dot size. So if it's small and the other size is not small, okay, size dot small, then we know it must come after. So this one must come before. So we return a negative number. So we could return -1. Okay. We're missing a bracket here. Okay. Now this is a long way round of doing things because there's a bit of a shortcut we can use. Okay. Similarly, we could say, well, okay, if size is size dot large and other dot size is not equal to size dot large, okay, then we want a positive number. Okay, if they're equal, so if the size is equal to the other size, we return 0. And I guess we haven't checked if it's a medium. So if size is equal to size dot medium and other dot size is I guess large, okay, then it comes before, so return -1. And then I think the only other option is if it's medium and the other size is small, in which case we'd just return a positive. Okay, so this should allow us to size out or compare our t-shirts by size. Okay, so let's just test that. Let's go back to our main method. Okay, the warning has gone because now collections.sort can sort t-shirts because it implements comparable. Okay, and then if we say for t-shirt, we need the class, don't we? T-shirt in t-shirts, and we'll print out t-shirt dot we get color plus t-shirt dot get size. Okay, let's just see what happens if we then run our code. So remember, we started off them in medium, large, small order, and now they're in small, medium, and large order. Okay. Now, quite often we don't actually need to do the hard work of manually ordering things. Now, yes, in the case of something like small, medium, and large, where they don't work alphabetically, we might have to if they were stored as strings. But there is a little bit of magic we can do here, because if we look at our size class, the way Java works is if we have an enum, it will automatically use the order that the items are stored in the enum. Okay. Now, obviously that does include a risk, because if someone's to come along and decide there's new and extra small size, then that could obviously break the process. So in this case, we put a comment above that says add sizes in the correct position. So how would we use the default size of something else? Okay, well, actually, because enums implement compare to automatically, all we need to do here is call the compare to method on the size of our t-shirt. So we could say return size dot compare to our other t-shirt size. Okay, and that should have the same result. So let's go back to our main class and run our code again. Okay, and we're getting the same result. Similarly, if we decided that for some reason large should come first, if we just modified our enum and go back to our main class and run it again, you can see the order has changed. Okay, now if for example we were comparing on color and we decided that actually we wanted it to be in alphabetical order of color, we could simply apply the approach to return color. Don't tell me I've put an American spelling for color. Gosh, I have. That's terrible. Let's just fix that. There we go. Okay, fix the spelling there. So we could say color dot compare to, and we could say other dot color. Okay, so now if we run our code, let's just check it didn't start in alphabetical order, the BRG yet, so it should go brown, green, red once it's in alphabetical order. We can run that again, and we can see it's now brown, green, red. It's in alphabetical order. Okay. With numbers, if we wanted to do it by price, if that was the default ordering, okay, we can't do price dot compare to because it's an int, it doesn't have any methods. But essentially, we've only got to return a positive, negative, or positive, negative, or the same number. So we can just do maths. We can just say return price minus other dot price. Okay, we just go back to our main class and modify this so we also show the price plus space plus t-shirt dot get price and run a code again. Okay, there we go, we're now in price order. Okay, so that's how we can use the compare to method. Okay, now obviously compare to only lets us choose one way of ordering our object. If you are thinking, well, hang on a minute, I want to have the ability to sort by lots of different properties, then that's certainly possible, but we need to create something called a comparator. Okay, and that's for another video.